We got one question there from Rudra 2016, which tool I use the most. These days, the tool I use the most is Visual Studio Code, because I am less of a hacker and more of a developer, because I'm actually building Binary Ninja now. So I'm like coding and building things a little bit more. So that's been an interesting change. But of course, I'd have to say Binary Ninja beyond that. All right. Yeah. License, is bug hunting considered personal purpose? That's a great question, actually, about licensing for Binary Ninja. So I don't actually have a lot of slides on the licensing, but we do have personal and we have commercial licensing. And we consider, if you're bug hunting for money, it is a commercial use. However, we have a cool clause that's actually in our FAQ. If we go to, let's see here, FAQ.binary.ninja, there is a, let's see. Yeah, there's a what do you consider commercial use question on our FAQ. And it actually explains that we have what we call like a de minimis standard. The idea being that if you're bug hunting for commercial purposes, but you haven't actually made any money yet, like you're not really commercial yet. And so like until you've made 5 times the cost of a commercial license, we just say like, look, don't even worry about it. We don't consider that actually commercial. So we encourage people to just use a personal license, do bug hunting, and then if they start making a good chunk of money with it, well then great, we'd love for you to convert that to a commercial license. We offer upgrades along the way. So with that, I think we are ready to get going. So I'm gonna go ahead and kick it off with the slides themselves. So the talk is finding bugs with Binary Ninja. To be clear, it is not finding bugs in Binary Ninja. That's a separate talk, and there's plenty of bugs to be found and ways you can help with that too. Yeah, ask me later, and we can kind of go into that. I'm Jordan Wiens. My bio is there. I've played a lot of CTF. I've done a decade of reverse engineering in VR. Ran some teams doing those things. I helped build Cyber Grand Challenge. I'm really passionate about capture the flags and how we visualize them and talk about them and present about them. And I am the worst developer of Binary Ninja. It's very important to make that clear. There's a reason that I'm the one giving the talks and the rest of the team is still working on the product because they're much better developers than I am. So Binary Ninja itself, this is like the slide I show like executives or like people that are like, what's Binary Ninja? Like, well, it's this. It converts bytes that the CPU runs into something that's a little more understandable for people, right? Obviously, I think the audience here probably has a better understanding of that. But we're taking the disassembly, or we're taking opcodes and we're disassembling it, and we're doing analysis on it for other things. So a couple clarifications of what it is and isn't. It is a reverse engineering tool. It's a disassembler. It's a program analysis platform. It's not a debugger. There's some debugging plugins, but it's not primarily a debugger. We're probably going to be expanding that out later this year. And it's also not a decompiler. Although I put a little, like, approximately not equal to that. I don't think that's valid syntax in any programming language, but hopefully you get what I'm saying. Because we have our intermediate languages that actually provide a higher level abstraction. It's a little bit like a decompiler, but is not. So I want to be clear, we do not yet have a decompiler. It is something that we're working on. All right, so what is Binary Ninja good for your bug hunting? It's good for PE Mako ELF. I left off something near the end. Raw binaries was the next one. If you just have any kind of binary executable code for x86, x64, RV7, RV8, MIPS, PowerPC, and then there's many others. There's links in the slide notes with all the other third-party architectures that we support. And firmware, some assembly required, right? You have to know a little about the firmware structure. We don't have built-in support for a lot of different firmware formats, but it's pretty easy to define where the code actually lives. More importantly, it's not good at web apps. It's not good for Java. It's not good for .NET. It's not good for virtual machines. It's not good for things that are not binary code. That's hence the name, right? So that kind of gives you a hint about it. All right, the design of Binary Ninja. I'm not going to go into a lot of detail for most of these, but I just kind of want to talk about like why it's built the way it is. It has a separable core, which just means that like the thing that does the analysis is distinct from the UI. The UI itself calls into the core, and it does that through the same API that any third-party plugin can use. And so that actually ties down to that fourth one of API first, that we really built the API is the most important thing, and then we build the UI on top of that. Now, we care about the UI a lot. We think usability in UI is really important, but from an analysis perspective, we build it based on the API, and that way, like, we're not cheating. There's no like API that only we can access to do special things. Like literally everything in the UI is possible via the Python console, via the scripting that you could do separately from the user interface, or if you were writing your own plugin to link directly into it. It's multi-threaded, so just, we built it for machines with lots of cores because it's 2019, we should do that. We have this cool idea called confidence. I'll talk a little bit more. And we have the illest design. My apologies for the bad joke. Hopefully that counts as entertainment for those of you who are demanding that earlier. We do a lot of our analysis on intermediate languages. And so I'll talk a little bit about the ILs because that's really the key focus of why Binary Ninja is good for finding bugs, is because of that IL design. So that separable core, I mentioned that UI calls into the same API plugins use. You can do something like import Binary Ninja. Now I do have to caveat briefly, there was a mention earlier about the personal license versus the commercial license. They're feature parity in almost every way, except for the commercial version. You will use more cores on your machine, just it's faster. It caches some of a little bit more of the analysis when you save an analysis database. And then the real kicker is the commercial version has a true headless support. And by which I mean you can do this. You can just like type Python, import Binary Ninja, and start scripting up and automating it. A lot of people though get confused and assume, oh wait, does that mean that Personal doesn't actually like support scripting in the API? No, it absolutely does. You just do it via the user interface. So when I actually like flip over to the console in a binary, I can still type in the API. I can access any of the things that I want to from the API. I just do it through this console, or I do it via a plugin that I've written and I can trigger. So you still have access to the same API. It's just not available without loading the UI. You can link to it from any language that can call into C or C++, which is basically every language, because C is such the standard for sort of binary API compatibility. And it's the DLL, DILIB, or SO, depending on your platform, that you can just kind of call into. Right? So that's the separable core. Multithreading, yeah, it supports multithreading. Not a lot to that. Confidence is this cool idea that I like to mention. It's something that doesn't show up right now in the current UI, but it's built into the core of how Binary Ninja works. And it's going to be more and more exposed as we develop more features that make it kind of available. This kind of came about from some conversations with Alex Soderov, who was like, hey guys, listen, you need to have confidence built into your tool. And we're like, well, what do you mean? And kind of as you explained it, we got pretty excited about it because it's a cool idea. Reverse engineering is about taking a binary where you've lost a lot of information. You've lost symbols. Sometimes there's debugging information in the binary, but right, like you've still lost, you don't always maintain all of the information that was in the source code. And then you're trying to recover that into a higher level abstraction, something that you can understand because you want to find bugs, because you want to modify things, because you want to interoperate with some API, whatever your purpose is, you want to kind of recover that higher level understanding. But that's a lossy process, right? It's not possible to perfectly recover in most cases, right? Like obviously something like Java, where it's designed to maintain more of that information, you can do a better recovery process. But with something like C or C++, you cannot perfectly recover all types of source code. Like it's just not possible because compilers are not meant to be reversible transformations. And so whenever you have these kind of guesses, and in fact, here's my first Twitch moment. Give me a thumbs up in chat if you've ever named a function, maybe, or put a question mark on it, or been like I think it's stir copy, but I don't know, or this looks like hash function, question mark, like you don't really know. Because I think if you've been doing a lot of reverse engineering, this is absolutely something that's come up. And so I think that demonstrates that like this is a lossy process, right? You don't always have full confidence in the assertions you're making. Like you're like, this is stir copy, I think. This is whatever I think. And so we actually have confidence built in to our data structures, and we use it internally, and we're going to start exposing that more and more, where you can actually like name a function and then say, hey, that function I just gave you that name of, I'm actually only 50% confident of that. And then we can make smart analysis decisions based on that, or we can like collaborative decisions. So when we pull data from multiple users and put it together, we can be informed based on like the confidence that you have. API first, there's the API docs if you want to kind of go dig into it. I'm not going to do that now. Intermediate language design. This is like several hours of conversation about the design of the IL. So these slides are just getting skipped. There are lots of levels of IL. They go from low level IL up to medium level IL. We're working on a high level IL that will be a part of the decompiler. Oh, there's no thumbs up. Oh, I mean, you got the emoji input. +1 works too. Yeah, that works as well. At least that's one. So there's one person who has named a function with a question mark or maybe. It's a tree-based IL. That really doesn't really matter, right? So what? Like, okay, great, you've got an IL. I want to show real quick a concrete example of why that sort of matters. So this is actually an IL view for a function. So if I look at the actual disassembly, this is a random old CTF challenge that I pulled up. You can see you've got a conditional statement, you've got some functions being called, you've got data being read from data segment, you've got stack variables being referenced. When you go to an IL though, notice it actually gets smaller. Like we've actually simplified the graph because we're throwing away some of those details. We actually don't care about the, all right, we got a few more, good. There's some good reversers in the chat here too, or at least ones that are willing to admit that they name things and they don't always know it sometimes. And so like we're throwing away things like the stack information. Like it's just a variable. Like you don't care whether it went on the stack or where it went somewhere else unless you're looking for stack-based buffer overflows, for example. But like when you're trying to understand what the program's doing, the programmer didn't say explicitly, put this variable on the stack, right? It was just a local variable they declared. And then the compiler handles that for them. And so conversely, when we do the opposite, we kind of get back to this. And so this is just much easier to read, first of all, like one of the advantages of it. And it's more concise. So it's actually like less to look at than if you're used to looking at the disassembly. Okay, so that's one thing. But there's a lot more to it than that. So first, program analysis techniques, I guess second, because I already covered one of them. But program analysis techniques often rely on these intermediate languages. They often require certain properties, like there's SSA forms, which allow you to, like you never write a variable, you only make a copy to it. So if you change a variable, well, you're actually just making a copy of it. And this relationship, when you've done your intermediate language, allows you to do things like really fast data flow and go back and track where things kind of came from. So there's important reasons why, from a program analysis perspective, you need intermediate languages. I like the write once, pwn anywhere aspect of it. The idea is that if you write a plugin on Binary Ninja to find vulnerabilities or to help you identify certain pieces of code, and you do it on the intermediate language, you write it once, right? You're not writing it for ARM and for x86 and MIPS and PowerPC. I mean, if you look at like embedded routers, right, where they've got a lot of the same flaws that come up in these routers, they're using the same OEM kits that have hard-coded backdoors or all sorts of kind of like low-hanging fruit. But oftentimes they'll be on different architectures, right? Like there'll be an ARM one, there'll be a MIPS one. So there's different CPUs in these architectures. Rather than rewriting your script, you write it once on the IL, which is easier to do. I mentioned the analysis of the results earlier. Like you can just read it and understand it a little bit more easily. And then different ILs are appropriate from different questions. It's kind of outside the scope of this short summary. But the idea is that, again, I said earlier, like if you care about something being on the stack and how far it is from the return address, for example, then you would want to use a different IL than you would want to use for a different question you might want to ask. For example, okay. So there are several good examples. Our friends at Trail of Bits, Sophia, Ryan, and Josh have all done blog posts and presentations and talked a lot about the ways that they've used Binary Ninja to find vulnerabilities, ways that they've identified flaws that they can generically search through the IL for. So there's some great posts there that I highly recommend you check out. I've got a link at the very last slide that includes a link to this slide deck, so you can get to all of these references as well. I think a tweet may have already gone out with it too from Vector35 Twitter with a link to the slides. The automated opaque predicate removal is not strictly a vulnerability finding task. It's just more of a reverse engineering one. But I think it's a really useful thing to talk about because obviously reverse engineering and vulnerability research are closely related when you're depending on the type of vulnerabilities you're looking for. And a lot of obfuscation and anti-analysis that happens that are reverse engineering problems can become relevant in vulnerability research. So we took a fun, had this blog post that Peter, one of the other co-founders of Vector35 did, where you identify opaque predicates. So opaque predicates are when things like an obfuscating compiler will make some calculation where it knows in advance the results of the calculation and then do like a conditional branch. It's not really conditional though. It just sort of looks conditional if you naively disassemble the code. And then so if you then follow both sides of the disassembly, you're going to end up like disassembling garbage, or you're going to end up misaligned. They're going to intentionally throw off your analysis, even though the program, when it executes, would never actually go down that route because it knows in advance, like, well, I know the EAX is currently 0 because I just set it to 0 4 instructions ago, and therefore I'm going to automatically, jump here of 0, and it's just really a straight jump. Like you don't ever want to treat it as a conditional. And so we showed how you can use the ILs, and you can clean up these sort of automatically for you and rewrite the binary to get rid of a lot of these obfuscations. So that's really I think the most powerful aspect of Binary Ninja. There's a lot of other reverse engineering tools that are very, there's several good quality reverse engineering tools that will do good work, and you can interactively sit down and you can create structures and comments and build an understanding of a binary. But I think that our focus has always been, again, on this automation, the idea of building code. Like doing something once is fine, but if you're doing it 2 or 3 times, well, at a certain point you should automate that. You shouldn't be doing that by hand. And that's where we think that working on the ILs makes a lot of sense. So I'm going to show one of these right now. We're going to pop open. This is actually, if I go back to the example slide, somewhat similar to the memcopy example that Sophia put up under the Trilobits GitHub page. It's a little bit, it does a few more things, but it's very similar in concept. The idea is that there are certain like dangerous functions, right? I think that like everybody knows a format string vulnerability is exploitable. And so like all source code scanners, a lot of like tools can detect format string bugs where user input goes straight into a format string. So there's certain like classes of things that are just really obvious. Memcopy should always be bounded, right? Like if you have a memcopy and the length of the memcopy comes from user data and the user can put whatever they want, well, that's like always bad, right? How bad depends on the context of where it's used. But so there's a lot of these questions you can ask on the IL. And we are going to look at a quick test program. So this is just a program that does some dumb things with memcopy, right? Like there's, again, several ways that you can do dumb things with memcopy. So there's a few samples. And then we have, so this is actually an example script that we use. We have a training class that we do on Binary Ninja. We're doing a 2-day version of it coming up at Infiltrate in a few months. And this is just like the relevant bits of it that iterate over the IL and look for interesting things. So because we have this intermediate language, we're actually doing data flow and be able to track static data flow, right? So we're not looking at like, what is the value of this argument to the function. We're looking at what are all the possible values that could come into this function. Was there a check beforehand that made sure it was less than 10 or less than 5, or was it signed or unsigned? So we do all these we'll do this range analysis, and we can actually check and say, hey, I know that this value must be less than 10 because of this check that happened beforehand. So it's safe because I know the destination buffer, for example, is only 10 bytes long. And so therefore it's always gonna be safe. Or what if the destination buffer I know is only 10 bytes long, but it's not bounded at all, or it's bounded by 45? Well, then we have the possibility for a buffer overflow. So that's the plugin there, and we're gonna kick it off on that test binary. So we've got this is the compiled form of that source. And let's look at it in the IL real quick, just because I always prefer the ILs. So we've got a couple of mem copies. Now this is obviously like a toy program, but if we run our memcopy validator, go to our log, this is normally, it always gets me, this is normally like the log error message, which is like, warning, warning, something terrible has happened. But in this case, we just mean the person who wrote this program did something terrible. And so you can see we've got some output. It's saying the possible values here, this is a range from negative maxint to maxint. So like, this thing is like not really limited. The possible size on the memcopy is unlimited. And if we look here, so you can actually see by hovering over the arguments here, like what our data flow knows about the limits on the arguments. And that's potentially a problem. Now, it may not be a problem. It may be that the functions that call this function bound those arguments. So it may still require some manual analysis. Like with any good tool, you've got to validate the results. And there's several other ones as well, right? So there's different things that we're validating. Is the destination on the stack? That's kind of back over on the IL as well. So all right, that is one example. Again, there are many, many more, and this is not meant to be. This is really just a short 20-minute kind of introduction to the concepts and where these resources are. So some of the other resources to get started with Binary Ninja, if you're interested. First, our API itself is actually open source. So the product is commercial. We thought that the best way to get the product built the way that we wanted it was to be able to be a commercial piece of software where we could put more resources and time into it. And but we do try to open source a lot of the components and several of the pieces. So for example, the API itself, which includes information on the intermediate languages, is all open source. We encourage other people, if you wanted to make different open source bindings, we try to make that as easy as possible. I know there's several people working on like Rust bindings, and I think I've heard a rumor of an OCaml binding. There's different ones kind of in development, but we primarily have C, C++, and Python as the main ones that we use. And just when I'm using Binary Ninja, I'm mostly using the console, quick and dirty little snippets that I'm looking at, that bv.functions that I showed here earlier, or current function.start, just to kind of interactively like poke around with binaries is actually really, really handy. So having that as a true like Pythonic console, and you can do iterators and normal kind of Python things is really helpful. Our user documentation is actually also a part of the GitHub repo. And so if you want to do a pull request for a typo, whatever, you're more than welcome to. The user documentation's online, the API documentation's online, the API documentation, user documentation are also both offline. So you can get those if you happen to be on an airplane, you can still pull up those docs, and you can even search the API docs, the offline HTML versions. We've got a FAQ, which I showed briefly. We've got a lot of examples. We've got the Slack, which has a really great community. I highly recommend, if you're all interested, please check out the Slack. There's a ton of people in there. There's a ton of different channels. There's ones just for people with reverse engineering questions unrelated to Binary Ninja. We love helping people get started in reverse engineering. And then there are several like sort of the unofficial help mechanisms. There's a community plugin repository, which has tons of example plugins you can look through and lots of nice functionality that you might actually want. Josh Watson has started streaming on Twitch lately. He's effing around with Binary Ninja. He's been doing that a ton lately. Those are super entertaining. He is really, really knowledgeable about Binary Ninja and fun to watch. So he's doing some cool stuff. Right now he's working on a deobfuscator for a like DRM style protection packer, which he's been building for fun. And then the Slack is both unofficial and official. So that's the end of my my slide time. If anybody has questions, there's the link to the actual slides. Oh, and thank you. Yes, Josh's Twitter was, Josh's Twitch was mentioned in the Slack chat as well. I should have mentioned that. Does it actually link? Can you click it from here? No, you can copy paste it to Twitch. So that's that. Yeah. Any other questions? See, there's a thumbs up. Told you could do thumbs up. Thanks. All right, I have to wait 8 seconds to make sure for the delay, make sure everyone's had a chance. I am actually at ShmooCon right now, so I'm here in DC. So I'm going to be heading back there, wandering around. Find me if you want some Binary Ninja stickers, if you happen to be in the area for it. If not, definitely come join us in Slack, and we'd love to chat with you more about any of this stuff.